Good evening, everyone. Thank you for coming. My name is Dirk Moss. I'm on the Town and Country Green Team Commission, which sponsors the speaker series. This would be a good time to turn off cell phones. And I'd like to acknowledge an alderman and an alderman-elect, Alderman Alan Gerber, and Alderman-elect Skip Mange from Town and Country, Gussie Crawford, Alderwoman-elect, I'm sorry, I've never met you. Nice to meet you. Thank you for coming. In the back there, on the way out, you will see a couple of ugly cardboard boxes with reusable grocery bags. Take as many as you like. There are 400 of them. I don't expect them all to disappear, but it would be nice not to have to take them back to my car. If you're not on the Green Speaker Series email list and would like to be, please see me after the talk. Tonight's presentation, as you know, is on climate change, and Brian Bozek is our presenter. He's originally from Massachusetts. He came to the Midwest to study mathematics in grad school at SIU Edwardsville. He's now a professor of mathematics at St. Louis Community College. And in 2007, he was trained by the Climate Reality Project to give the presentation that Al Gore gives in the movie An Inconvenient Truth. And you've given the presentation about 35 times, is that right?
That's right.
So please welcome Brian Bozek.
Thank you. First of all, I'd like to say it's nice to see the aldermen come out here. It's important that local officials get this message. It's, the everyday person, we all do our fair share to take care of the planet and the climate and do what we can, but it's the people who make the decisions who will make the real changes. So thank you for coming out. So to start off, I'd like to tell you a little bit about a little bit about myself, to help you understand a little bit why I feel so passionately about this issue. I'm a product of the 80s. I went to high school and college during that decade, and that was when I first started to become aware of international events and things like that. And as most of you know here, during that time, whenever you read a newspaper or listened to the evening news, chances are you saw a news item about the Cold War. And of course, with the United States on one side and the Soviet Union on the other. And throughout the long history of the Cold War, there were a lot of conflicts that had taken place between the two sides. But there were a lot of conflicts that could have taken place that didn't. And as it turns out, there were analysts on both sides of the conflict who were analyzing and categorizing all of these conflicts depending upon the theater within which they took place. There were local skirmishes. An example of a local skirmish might have been when Gary Powers was shot down over the Soviet Union in his U-2 spy plane. I mean, that event could have turned out to be something much greater than it was, but it remained a localized event. And then there were regional battles. We fought wars in Korea and Vietnam, and in the mid-80s we helped the Mujahideen push the Soviets out of Afghanistan. And then the third category we called strategic conflicts. This category was reserved for struggles that would endanger our entire nation. And as we all know today, fortunately, we never did engage in a strategic conflict. But today, environmental threats can be categorized in very much the same way. Some examples of air pollution and water pollution and illegal dumping, that's a localized event. And examples of regional battles, we fought wars in Vietnam and Korea. Some examples of air pollution and water pollution and large oil spills are regional in nature. And when a lot of these localized and regional environmental threats occur simultaneously, the threat may seem global, but the threat isn't truly strategic because the working order of our environment isn't affected, and the survival of our civilization is not at stake. But unfortunately today, climate change is an example of one of these environmental threats that falls into this third most dire category. And furthermore, we as human beings have initiated this conflict with the planet. And that's the bad news. But the good news is that if we act boldly and quickly, there's still time to take a step back and solve this crisis. So for the next 40 minutes, I'd like to take you on a virtual tour of the planet, show you what's going on out there. Christmas Eve 1968, Apollo 8 was on a mission to search for suitable landing sites on the moon for the Apollo 11 mission that would take place the following summer. And as the craft went around the moon, radio contact was lost, as expected, but it still was a pretty nervous time in mission control. But as the craft came back around again, and as radio contact was reestablished, the astronauts looked up to see this sight. And this picture is called Earthrise, and was taken by rookie astronaut Bill Anders. And this is the first time human beings had ever seen a picture of Earth from space. And this picture had an amazing effect on the collective psyche of everybody in this nation, for sure. For the first time, we saw Earth as kind of a place made up of finite resources, not of infinite places to extract things that we normally use. Within 18 months of this picture being taken, the first Earth Day had taken place. The Clean Air Act was passed. The Clean Water Act was passed. This is the very last picture of Earth taken from space by a human being. This was taken on December 17th, 1972 during the Apollo 17 mission. And as you can see in this picture, Earth is fully lit and not partially covered in darkness because when the spacecraft came in to land, the sun was directly behind the spacecraft. This is the most commonly photographed picture in all of human history. Matter of fact, 99 times out of 100, when you see a picture of the Earth, this is the picture you're looking at. These next few images were created by a fellow by the name of Tom Van Zandt. He searched through 3,000 satellite images over a 3-year period, and he digitally stitched together all of the ones that gave cloud-free views. Each landmass is accurately portrayed, and when they're all stretched out, they create this iconic image. We've seen this in many atlases, including National Geographic. Now, one time, the scientific community thought that the continents were so big that they couldn't possibly be moving. But today, we know that they were wrong about that assumption. And this reflected a well-known proverb at the time. What gets us into trouble is not what we don't know, it's what we know for sure that just ain't so. Hometown favorite. Well, there's another assumption that a lot of us have about global warming that just ain't so. And the assumption is that Earth is so big and so vast that we cannot possibly be having any lasting harmful impacts on its environment. Well, that may have been true at one time, but because we've grown so populous and because our technology has become so powerful, that isn't true any longer. Of all of Earth's ecological structures, the atmosphere is the most vulnerable because it's so thin. Carl Sagan once said that if you took a basketball and covered it with a coat of varnish, the thickness of the varnish of the basketball is comparable to the thickness of Earth's atmosphere to Earth itself. The fact of the matter is that we are powerful enough and capable of changing the composition of our atmosphere. And this leads to the basic science behind global warming. Solar radiation in the form of light waves passes through the atmosphere. Most of it is absorbed by the Earth and warms it. But some of it escapes back into space in the form of infrared waves. But some of these outgoing infrared waves naturally get trapped by the atmosphere. And this is a good thing, because this keeps Earth's temperatures within stable and livable boundaries. If this didn't happen, we would not be able to live on this planet. But what's happening today is that we are starting to put so much global warming pollution into the atmosphere that the atmosphere is actually starting to thicken up. and consequently more and more of these outgoing infrared waves are becoming trapped. Here's a picture of Earth. Here's a picture of Venus. Earth and Venus, just about the same size, just about the same amount of carbon. The main difference is that most of the carbon on Earth has been deposited into the ground by various life forms over the last 600 million years, while most of the carbon on Venus is in its atmosphere. The consequence is that the average temperature on Venus is 855 degrees Fahrenheit, while the average temperature on Earth is only 59. Now, I know what you may be saying. Of course it's hotter on Venus because it's closer to the sun. Well, if you take a look at Mercury, Mercury's a lot closer to the sun than Venus, yet it's almost 3 times as hot on Venus as it is on Mercury. The fact of the matter is that it is all of this excess carbon in Venus's atmosphere that is causing it to be so hot. It's actually interesting to note that it rains sulfuric acid on Venus. An umbrella would not help during those events. The first person to suggest measuring the levels of carbon dioxide on our planet was Roger Revelle. In 1957, he hired Dr. Charles David Keeling to help design an experiment to do this. Dr. Keeling was very faithful and precise in taking his measurements over many decades. They took their readings over the middle of the Pacific because of its remoteness. And after the first few years of collecting data about how much carbon was in our atmosphere, they noticed that the level in our atmosphere spiked up and down like this. And of course, the first question was, why does the amount of carbon in our atmosphere spike up and down so drastic? Well, not much of the Earth's landmass is below the equator, while most of it's above the equator. Consequently, most of the vegetation on the planet is above the equator. And when the northern hemisphere is tilted toward the sun like it is during our summer, in spring, vegetation comes out, leaves come out, carbon dioxide is taken in, the amount in the atmosphere goes down. But when the northern hemisphere is tilted away from the sun like it is during our winter and fall, vegetation dies, carbon dioxide is released, the amount in the atmosphere goes back up again. So it's as if each year the Earth takes in a big deep breath of carbon dioxide and lets it back out again. And we can follow this pattern to present day. And even though the amount of carbon in our atmosphere spikes up and down like this once each year, the general trend is increasing and it is relentless. And we're starting to see the effects of this all across the planet. Here's a picture of Mount Kilimanjaro in 1970. Here's how it looked in 2000. Notice how far the ice cap has retreated. Here's a picture of Kilimanjaro in 2005. This is Dr. Lonnie Thompson. He's from Ohio State University. He's considered one of the world's leading experts on glaciers. Here he is on Kilimanjaro with one of the last pitiful remnants of one of its once great glaciers. Dr. Thompson predicts that within a few short years, there will be no more snows of Mount Kilimanjaro. Boulder Glacier National Park, taken in 1932. Here's how it looked in 88. We will soon have to change the name of this park. And this is, of course, in the United States. Here's a picture of the Portage Glacier in Alaska, 1914. Here's how it looked in 2000. Now, sometimes people say, is one of these a winter shot and one of these a summer shot? That's not the case. This is, these glaciers don't refreeze and melt again. So these are permanent changes. Here's a picture from Argentina, 1928. A composite image of the same area in 2004. Many of the Earth's mountain glaciers are melting and retreating at a very rapid pace. The process of ice falling off face of glaciers is called calving. Here's the Corey-Callis Glacier. This was taken in 1978. I have loads and loads of slides of different glaciers that I can scan through for before and after or comparison shots. And I put this one out because this one is 1978. That's not that far long ago, at least for for me, for most of us. Here's how it looked in 2006. Picture the Hotel Belvedere on the Rhone Glacier. This is a 1906. Here's how it looked in 2004. Permanent changes. This young man died about 5,300 years ago. He was discovered in 1991 due to melting ice. He was nicknamed Otzi. Many of the world's great rivers find their origins in the Himalayan glaciers. There's the Indus, Ganges, Brahmaputra, Salween, Mekong, Yangtze, Yellow. About 40% of the world's population gets about half of their drinking water from the Himalayan glaciers. Unless we act boldly and quickly to mitigate the effects of climate change, many of these people may soon face serious shortages of drinking water. Here's Dr. Thompson's team in Peru. Ice cores are drilled, brought to the surface, and studied. When it snows out, small amounts of atmosphere get trapped in the ice, and scientists can look at these small bubbles of atmosphere, and they can determine how much carbon dioxide was in the atmosphere during the year that that bubble was trapped. They can also look at the different isotopes of oxygen in those small bubbles, and they can determine the temperature during the year that that bubble was trapped. And they can read back year by year, a lot like how a forester reads tree rings. Here you can see each year separated by the annual melting and refreezing of the ice. In many mountain glaciers, you can go back about 1,000 years. Here we see 1,000 years worth of temperature readings in the northern hemisphere. Here we see 1,000 years worth of carbon dioxide concentrations in the northern hemisphere. Notice how nicely these two graphs fit together, this relationship between temperature and carbon dioxide. In many mountain glaciers, you can go back about 1,000 years, but in Antarctica, you can go back 650 million, or 1,000 years ago. 650,000 years ago. And to the right, this is modern day, and you can count back about 7 ice ages. 1, 2, 3, 4, 5, 6, 7. You can count back about 7 ice ages. And here are the temperature readings taken from the same time period. Now, again, notice how nicely these two graphs fit together. Now, the relationship between these two is very complicated, the relationship between temperature and carbon dioxide. But there's one part of the relationship that's a lot stronger than all the rest, and that's when there's more carbon dioxide in the atmosphere, the temperature goes up because more of the sun's energy gets trapped. Now, taking a look at the temperature graph, here, this is in many parts of North America, this is the difference between a nice day on Earth and having a mile of ice over your head during the last ice age. Getting back to the carbon dioxide levels, it's important to note that over this entire period of time, 650,000 years, the amount of carbon in our atmosphere has never gone above 300 parts per million. Of this entire amount of time. But today, we are at about 390 parts per million. And this steep increase in carbon in our atmosphere has taken place since the Industrial Revolution. And if our current energy consumption trends continue as usual, it's predicted that within 45 years, we'll be at about 600 parts per million. I hit that bumper twice. Be at about 650 parts per million. 600 parts per million in about 40 years if we continue the way we are today. Now, if this much difference on our graph, about maybe 2 feet, is the difference between a nice day on Earth and having a mile of ice over your head on the cold side, imagine what this much difference would be like on the hot side. Allowing this to happen is deeply immoral. Here we see tropospheric carbon dioxide concentration levels. This was July of 2003. Here's how the same dispersion looked in 2008. Back up one more time. July 2003. The red is where it's more concentrated at about 386 parts per million. And notice the dispersion is not that wide with the red areas. But as we get to 2008, look at how many more areas are affected by the more concentrated areas, or will have the more concentrated areas. I think this is a very intriguing set of images, at least for me. I kind of like this, or I think it's interesting. It kind of shows where surface CO2 is emitted from our country. And it's obvious, the eastern seaboard, the Midwest, Gulf of Mexico, and San Francisco and Los Angeles areas, where we, in our country, emit surface CO2. 10 hottest years on record occurred within the last 13 years. Now this slide hasn't even been updated to take into account last year. So when those numbers come in, every year when as the years go by, I consistently change this slide. 2010 was the hottest year ever measured, statistically tied with 2005. Here's a city in Pakistan, 128 degrees Fahrenheit. Highest temperature ever recorded in an Asian city. Here's a lake in China, 122 degrees Fahrenheit. Highest temperature ever recorded in China. Here's a couple cities in Iran and Iraq. 127 degrees Fahrenheit. Highest temperature ever recorded in either country. And this picture, I think, is amazing to me as well. This was taken in Los Angeles in September 2010. And what I find so intriguing about this is that people actually stopped to take pictures of how hot it was. And not only that, but this is where the thermometer broke. Oh, this next slide takes a little bit of time to load up. Happens to me every time. Summer of 2011, over 200 cities broke or tied all-time high temperatures for that summer. Over 6,000 daily high temperatures were either tied or broken. And during that summer, all 50 states broke or tied all-time high temperature records in July. So not only are atmospheric temperatures rising, but so are ocean temperatures. This blue line shows the natural variability of ocean temperatures over the last 60 years. This green line shows the projected variability of ocean temperatures over the last 60 years due to human causes. Blue line, natural. Green line, due to human causes, predicted. This red line shows the actual ocean temperatures. Again, notice how the actual temperatures are falling in line with the projections that were made due to human activity. And as we all know, warmer oceans create much more intense hurricanes. Models show a decrease in the total number of hurricanes by the end of the century, yet still producing nearly a doubling of Category 4 or 5 hurricanes. Hurricane Ike, 2008, destroyed Galveston, Texas. Now, I'm not sure if you would like to live in this house or not. I mean, maybe. Unless you needed to borrow a cup of sugar. I try out new jokes from time to time. I don't know, it'd be lonely there, I guess. Then, of course, there was Hurricane Irene that raced up the eastern seaboard this past summer. Damages could reach a total of $12 billion. My hometown was affected by this, as was most of the East Coast. This slide takes a little bit of time. Killington, Vermont. This is just an example of some of the devastation that state saw. We didn't used to get weather patterns like this in Vermont. We didn't get tropical storms. Our storm patterns weren't like Costa Rica. They were like Vermont. Spoken like a true Vermonter, governor. Then, of course, there was Katrina. It's important to note that as Katrina raced over the southern tip of Florida, it was only a Category 1, yet it caused a lot of damage and killed a good number of people. But before Katrina made it to New Orleans, it went over that warm water in the Gulf. And let's watch as we see Katrina form over the Atlantic and watch it pass as a Category 1 over the southern tip of Florida and get all that excess energy in the Gulf, and look at it slam into New Orleans with how defined that eye was. The consequences were so devastating that there are no words to describe what happened during that event. But there were scientists who predicted that this storm could do this type of damage. Now, we as a people need to ask ourselves, the question we need to ask is, how will we react in the future when we get warnings from the world's leading scientists? Another effect of climate change is that it produces more precipitation to fall during one-time large storm events. Increased evaporation puts more moisture in the atmosphere, and when conditions trigger a downpour, more of it comes down. The Great Australian Flood of 2011 covered an area the entire size of France and Germany combined. Here's a picture of Rosalia, neighborhood in Queensland. I think that these two before and afters are extreme. They kind of capture my, I don't know if imagination is the right word. This next one will be Rockley. Just how the before and after is so amazing to me. Before and then after. And these are situations like this are played out across the planet. I mean, you can again, I'm pulling a small sample of slides. This is an area of Pakistan. This was in the summer of 2010, September 2010. This shows the areas where there was severe flooding in red, moderate flooding in yellow. 20 million people affected affected by flooding, further destabilizing a nuclear-armed country. I mean, in the news we consistently hear about how concerned we are with the situation in Pakistan due to human activity again, but in addition to flooding. This is a picture of a supercell outside of Glasgow, Montana. This was in July of 2010. This is a huge column of rain in the middle. This is a picture of Mays Island in Iowa, 2008. This was called a 1 in 500 year flood. Here's another shot of the same flooding. Now, again, there's so many slides that I think are interesting to me. But this one is particularly interesting because one time I was giving this slideshow to middle schoolers, and one of the girls or guys, I can't remember, jumped up and said, "Do you know what's so weird about this picture?" And I said, "I don't know." And the student said, "Guesses?" The student, I was like, "Oh, it looks like some pretty devastation." But no, the student said, they parked the trains on the bridge to help stabilize the bridge for the flooding. I think that's thinking, but I suspect that bridge held. Those houses didn't, of course. And then, of course, a little bit closer to home, May 12th, actually May 3rd of 2011, the Army Corps of Engineers blasted a 2-mile-wide hole in the Birds Point, New Madrid, the levee protecting the the Birds Point, New Madrid floodway in an effort to save Cairo, Illinois. This event killed a couple people and was responsible for at least a couple $2 billion worth of damage. Just another price we're paying for all of this carbon being placed in our atmosphere. Then, of course, there's flooding in Memphis. They received over 13 inches of rain in a 2-day period, tying a previous high record. And then another problem that happened is that, this was a once in 1,000 year flood, but another problem that's happening is that a lot of people are losing everything they own because their homes are outside of federally or state flooded areas, and with the or flood zones. And with the frequency and the intensity of these downpours, these zones will have to be completely redrawn. Here's another, just another example of many of flooding. This was in just this past summer, 2011. Minot, North Dakota. Again, this one is interesting for I picked this one. I kind of liked the effort by this business to try to save themselves. I think they made it. Largest flooding in the recorded history of North Dakota. Now, not only does climate change suck moisture out of the oceans that seed clouds that produce torrential downpours, but it also rapidly increases drying of our soils, sucks the moisture right out of our land that contribute to drought conditions. So not only does climate change produce these torrential downpours, but it also produces drought conditions, many times situated very closely to each other. Here we have a few shots in southern Yunnan province in China. This was March 2010. This was China's worst drought in more than a century. Here we see a villager walking across this parched land. We see this fellow, it looks like he's having a difficult day of it. And here we see some villagers trying to catch something in a reservoir. Not sure how wise that is, but these desperate times produce desperate measures. Here we see many barges that are banked on the Yangtze River. This map shows the areas of drought conditions in China of 2011. Again, the brown is extremely dry, the red is severely dry. Almost half the country experienced conditions like this. Increased evaporation and drying of soils results in expanding and creating new deserts. This is a shot of the Gobi Desert encroaching upon farmland. This is very interesting. I'm not going to say anything. Isn't that amazing? Droughts are one of the factors that cause dust storms. That was a time-lapse video of a giant dust storm over Phoenix, Arizona. U.S. drought conditions during the summer of 2011. Again, red was extremely dry, and red is exceptional drought, the dark red to brown, and then the red is extreme drought. Now these next few images show projected potential for drought over many population centers across the planet. And as we look at these, the white shows where the drought will be most intense, and the blue is where it isn't. Here are drought potential from 2030 to 2039. And as you notice as we go through these, the area around the Mediterranean basin looks like it's getting a lot more, the drought potential is becoming much more serious. And this is a drought potential. This is based on our current emissions of carbon dioxide, 2060 to 2069. And then from 2090 to 2099, by the end of the century. The Mediterranean, it looks severe drought potential, upper Midwest as well. Now, in recent years, fires are being created at an increasing rate due to conditions such as pine beetles, drought, lightning strikes, and high temperatures. Here's a picture from Bastrop, Texas. More than 1,000 homes were burned. 3,000 acres were burned during this event. This was just this past summer. This next slide, so we get past this guy. This next slide here shows, well, this slide shows that 252 out of 254 counties in the state of Texas have experienced wildfires during this year. And of course, this chart just shows that with higher temperatures, the frequency of fires is correlated. Last three decades, the wildfire season in the western United States has increased by 78 days. I find that to be amazing. In 3 decades, the fire season in the western United States, they've said we've got to increase this by 78 days. Here's a shot from Los Alamos, New Mexico. Again, you know, this is where highly enriched nuclear materials were stored. Here's a picture of Griffith Park outside of Los Angeles. This next slide is, I think, something interesting. Here's a picture from Victoria, Australia. The red areas show where the fire is actively burning. These are in the Berry Mountains. And this slide is, I mean, the fire was so outrageous and just difficult that a wild koala bear was looking for help from a human being. I find that this slide is just amazing to me. A canary in the coal mine. The Arctic, the floating ice cap, and the Greenland ice sheet. I say canary in the coal mine because the Arctic is experiencing experiencing the effects of climate change much more rapidly than anywhere else on the planet. This is a picture of the Ward Hunt ice shelf, split directly in half in 2003, astonishing scientists. Starting in 1957, the United States Navy kept track of how thick the ice was in the Arctic because they could surface their submarines where it was 3.5 feet thick or less. Starting in 1970, we can see a precipitous drop-off in the amount, extent, and thickness of the ice cap. And by... It's not my thought process, it's the slides. And by 2007, it had decreased by 40%. The extent of the ice cap had decreased by 40% in just 40 years. Here's the extent of the ice cap. This is a summertime shot in 1980, the extent of the ice cap. And here's a 2007 summertime depiction of the extent of the ice cap. Now, there are predictions out there, and when I read about these predictions, it seems on various topics that the things are coming true a lot more quickly than these predictions have been benchmarked at. Within a few short years, there are predictions that during the summertime, the Arctic will be completely ice-free. I find that to be an astonishing event if that happens. A completely ice-free Arctic during the summertime. These next time-lapse images I think are pretty interesting. It shows the composition of the ice in the Arctic. The dark red shows the permanent ice. And we can see that how each summer, more and more of this permanent ice is melting and sliding past Greenland into the northern Atlantic. I guess the analogy is it seems like a beating heart each year, as told to me. Here's the composition and the extent of the ice cap in 1981. Quite robust, with a lot of areas were 5.5 feet thick of ice. And here was the extent in 2007. Now, you may be asking yourself, why is it heating up so quickly in the Arctic, and why is this a problem? Well, the ice cap acts as a giant mirror, keeping the Earth cool. More than 90% of the Earth's sun and rays get reflected off the ice cap and bounced back into space. But as that ice melts, and as that open ocean receives that energy instead, more than 90% is absorbed. So for this reason, the Arctic is experiencing a much quicker buildup of heat than anywhere else on the planet. And this is not good news for our friends, the polar bears, who depend upon ice for survival. Scientists are finding that more and more of these bears are dying because they have to swim just a little bit further for that next piece of ice. These are called drunken trees. Their roots are in the permafrost, and when the permafrost melts, they start to sway every which way. This house was built on permafrost, and when the permafrost melted, the house gave way. This graph here shows the number of days per year when there was frost on the ground in southern Switzerland. Number of days per year with frost on the ground in southern Switzerland over the last 100 years. Notice the precipitous drop-off of the number of days with frost. This part of the graph shows the exotic invasive species that have rushed in to fill the newly created ecological niches. Same thing's happening here in the West. We're finding that our western pines are becoming devastated because pine beetles are surviving during the warmer summers. Here we see parts of 16 million acres of spruce trees in Alaska that are dying off as the number of pine beetles grow as the temperature grows. Many great cities were founded above the mosquito line. Harare was one, Nairobi was another. And what's happening is that mosquitoes are following warmer temperatures to higher altitudes. And we know that this is not a good thing because mosquitoes are a vector for disease. 1999, West Nile virus first visited the eastern shores of Maryland. Within 2 years, West Nile had reached the Mississippi River. And within 2 years after that, West Nile had reached all the way to the Pacific. Now, not only do we talk about all of the consequences of climate change, but there are other consequences for being so dependent upon fossil fuels. We all experienced the Deep Horizon oil rig. It flowed for over 3 months, and it put more than 4.9 million barrels of oil into the ocean, killing 11 people. Never mind the wildlife that was devastated by this event. We saw a lot of these images on the news at the time. Well, some of them. This guy made it. So here's where I'd like to end. Humanity already possesses the fundamental scientific, technical, and industrial know-how to solve the climate crisis for the next half century. Wind is an extremely important source of renewable energy. It's available right now. Many people feel that turbines are an eyesore. But to me, they're beautiful. I like driving down the road and seeing a set of wind turbines. Think of it as modern art. The wind industry has employed tens of thousands of people in this country to install and maintain wind turbines. Here's a picture of well, they've employed, among others, people who climb cliffs to help service these turbines. And that picture shows just how huge those blades are. But only one of the top 10 producers of wind turbines is located here in the United States. As of 2009, the United States had more wind energy capacity than China, but during that year they added a lot more. Now, the country that fosters the wind industry is going to open up huge global marketplaces for that made in that country product. If you'd like to see more made in America around the world, encourage the wind industry, the solar industry in this nation. Top 10 installed and planned capacity by states. I think this is interesting. Shows that where most of the wind capacity is in America, Texas is by far leading the way. I don't see Missouri on here, but we do have Illinois. Solar, extremely promising form of alternative energy. Now, an hour of the Earth's rays striking the Earth, only an hour of the Earth's rays striking the Earth has enough energy to supply the electrical needs for the entire planet for an entire year. I find that to be an astonishing fact. An hour's worth of the sun's rays, equivalent to a year's worth of electricity for the entire planet. What a resource to take advantage of. This is called the power tower. This is located in Spain. There's a huge array of mirrors that reflect the sun to a tank on top of that tower where steam is produced, where it spins a turbine to generate electricity. Here's the Vatican. Over 1,000 photovoltaic panels installed to supply energy for lighting, heating, and cooling for one of the audience halls. And again, the entire world is leading the way and leaving America behind. Only one of the top 10 producers of photovoltaic paneling is located in the United States. Then, of course, there's hydropower. It's produced when falling water flows through a turbine to produce electricity. The Hoover Dam, about 726 feet tall. It produces about 4 billion kilowatt hours each year. The largest project in the world, Three Gorges Dam, produces about 20 times as much as the Hoover Dam. About 20 times as much. The number of homes powered by hydro, state by state. Washington leads the way, the upper northwest. Then there's geological power here. And this is very intriguing because it's readily available. You don't have to depend upon the wind. You don't have to depend upon the sun, geothermal. And the way this works, of course, is that when cold water is pumped into the Earth's molten mantle and it heats up the water hot enough to produce steam to turn a turbine to generate electricity. These next few slides, I think, show where geothermal is available in the United States. This is how far you have to go down to get to 300 degrees Fahrenheit or more. The blue is 3.5 kilometers, green 6.5, yellow go down 10 kilometers, you can get to 300 degrees. And then in some places where geothermal is hot enough to produce steam to turn a turbine to create electricity, that's great. But in some places where it's not hot enough to produce steam, it's still hot enough to heat homes. That's the way most of the homes in Reykjavik, Iceland are heated. There's a huge array of underground pipes that go throughout the basements of all of these buildings that pump this warm water to heat many of these homes. Now, wouldn't it be great if there was a machine that could take this carbon out of the air? Well, there is. It's called a tree. Here we see people in India planting trees. China leads the way in planting trees each year. They employ their army to help do this. Now, we all contribute to global warming, but we all can be part of the solution in the decisions that we make and what we buy, where we drive, how we lead our lives. The basic question comes down to this is, are we as Americans capable of doing great things, even though they may be difficult? Well, the record indicates that the answer to that question is yes. We fought and won a revolution. We founded a nation based on individual liberties. We desegregated our schools, and we passed civil rights laws to help remedy the injustices done to minorities. We even put a man on the moon, the very thing that we're capable of when we're at our best. It's time to use our democracy and our ability to reason with one another to help solve this crisis. We must avoid leaving behind a degraded, diminished, and harmful planet for our children and grandchildren. Here's another picture of Earth spinning in space. When one of those spaceships got about 3 or 4 billion miles away, Carl Sagan suggested turning those cameras around to take another shot of the Earth. Now, do you see that pale blue dot in the upper right-hand part of this picture? That's us. Everything that's ever happened in all of human history has taken place on that single pixel. All the triumphs, all the tragedies, all the wars, all the diseases. And it is our only home. And that's what's at stake here. Our ability to live on planet Earth as a civilization. Thank you. So I'd be interested in taking a couple questions if anyone has anything for me. Okay, thank you very much. I'll be leaving now. Anything catch your attention? No? All right. Yes, sir.
I read that the production of meat protein is actually one of the largest producers of methane and carbon gases. Is that indeed true?
Well, I don't know if it's as severe as that, but I do agree with you that it's a major problem. Not only that industry certainly does contribute, but not only the methane aspect, but the production and the transportation of all of the meat and things. There are many people who advocate becoming vegetarians to help combat this problem, but I don't personally think it's one of the leading problems. Like I'd have a steak now and again. Anything else? Yes, sir.
Talk about recycling. Is it worth it? And why?
It certainly is worth it. Now, it's a necessary condition that all of us do what we can do to help fight this problem. We all need to do every little bit that we can. I personally recycle quite a bit, and I try to do other little things in my life to help contribute to the cause. I try to use canvas bags when I go shopping. When I run errands, I try to string a few events together to not drive my car excessively. It's a necessary condition, and not only is it necessary because all of us, a sense of community and all the rest, but it also brings added revenue to a lot of municipalities. A lot of towns institute these recycling programs and they make money off it. So it's necessary, but it's not sufficient. We, I believe, need to take action on the national level. So when people speak about, recycling and things like that, I say, yeah, go for it, it's great. But I think that most important is to learn the names of your representatives and your senators and keep abreast of some of the legislation as it's passing through Congress, because I think that to truly meet this challenge, it will take laws to be passed. When President Obama was first elected, there was a cap and trade bill that was passed through the House of Representatives that was promising. It wasn't everything that the environmental community wanted, but they were for it and they were extremely excited about it. But we know that it died in the Senate. So yeah, do your thing, recycle, reduce, reuse, and all the rest. But what I try to do is, if I see something in the news, I try to contact, Mrs. McCaskill in particular. She's more amenable to these types of arguments. Is that any other questions?
Yeah.
Sure.
You mentioned dams as a way for energy, but how do we rectify the issue that's causing
again, I agree with what you say, and there are, when you say that, I agree. And today there are a lot of dams in the Northwest that are actually being taken down, and I think it's good that they're being taken down for the local reasons. I think it's one of many things we need to do to combat the crisis. Hydro is just a small part of it. Even with the recent events in Japan with the nuclear reactor, after that's gone down, that entire country is thinking about saying no nuclear because of those dangers, and they're thinking about shifting to coal. I think personally, I'm in favor of nuclear power. I know a lot of the many environmental groups that aren't. I'm in favor of hydro, but I think the thing that keeps me in mind is, each of these energy sources can cause problems locally, but in the this grand scheme of things, I think that hydro will play an important role. But I do agree that the salmon in the Northwest and other problems for sure.
I met a coal miner, a woman who was working in Wyoming, and she was telling me that, while America has good, clean, as clean as they can do it, they have operations to do clean burning coal. We sell a tremendous amount of coal to China, and they don't.
Right.
They don't have any.
Right.
What can we do?
Clean coal is it's so strange. It drives me nuts when I hear the term clean coal. I don't know.
But they don't know that China's not doing anything.
Yeah, but as China emerges on the world stage, there will be more and more pressure being placed upon them to become global citizens, I think. And even with the Keystone Pipeline, there were a big effort to stop that going through the United States, but then Canada turns around and say, well, we'll just, take a right-hand turn and ship it off to China. Yeah, and that's again, I think it's an amazing problem, and it's gonna take all of the nations of the planet coming together to sit down and make some decisions about this stuff. And that's why a lot of these summits, I think the last one was in Durban, are disappointing, because every individual actor is acting towards their own best interests. And China's saying the most important thing for us is they're saying, listen, we can't worry about the environment because we need to get these people out of poverty. Well, I don't know if that's they want to be a global superpower. And and they say to the United States, don't criticize us. You guys have been doing this for the past. All of that carbon in the atmosphere is because of what you guys have been doing for the past 100 years. We've just started. And so, I think that the argument that we're doing is turn around to China and say, hey, listen, can you try to learn from our mistakes and do things a little better than the way we have? So I agree with that. Yes, sir.
It seems to me like global warming caused by carbon is very controversial. We really haven't gotten into that.
Yeah.
And there are many people that don't believe that it's caused by carbon, and there are academics that also, very, very smart, common people, disagree with what you're saying. Now, is this a theory? Is this a fact? And if so, how come everybody's not on board and say, well, this is the way it is?
Right. I agree. I agree that there are a lot of people out there who have that opinion, and I do have a couple slides here that if I can get to the end here. Those who deny the existence of the climate crisis often claim there is no scientific consensus. However, every National Academy of Science of every major country in the world confirms anthropogenic global warming. Every National Academy of Science of every major country in the world academies rejecting the science of anthropogenic global warming? None. Here's what the national academies are saying. The need for urgent action to address climate change is now indisputable. So, I'm not here to, say, put dispersions upon people who deny that humans are, who call this just a theory and shouldn't be taken seriously. But every major scientific institution in the entire world disagrees with that. And I just think, as I wake up every day and watch the news and see things happening out there, it seems pretty clear that it's human caused, in my opinion. Just with all the anecdotal evidence possibly. Yes.
You referenced 7 documentable ice ages.
Right. Yes.
The cause of those were what?
Ice ages are caused by, I think, how the Earth wobbles. So when there's a wobbling in the Earth over a certain or long period of time, the axis changes a little bit and we get an ice age.
So would it be from volcanic action, putting a lot of carbon in the air or something like that? Or?
Oh yeah, I've heard that argument as well. Let me see if I got something here.
But this is happening so much faster than
That's right. Well, now, in terms of ice ages and things like that, I've had some people say, well, isn't it good that we're heating up the planet to combat the next ice age? Where the global warming will, battle the coldness. But I think that the effects of climate change will take their toll a lot more quickly than the next ice age comes along. Let's see. Okay, let's check this. Okay. Yeah, let's check this here.
When you look at a volcanic eruption, which I've seen scientists reveal that this could be 50,000 times what man's involvement in terms of creating CO2 would be, you begin to scratch your head and wonder, wait, what is it?
Red herring. Definition of red herring: something intended to divert attention from the real problem or matter at hand. Reality: which source emits more CO2, volcanoes or humans? .26 gigatons per year from volcanoes, 35 gigatons per year from humans. So 230 times more on the high end. Anything else? Okay, thanks. Yes, Dirk.
Okay, one last question. I know the United States is not taking the lead in fighting global warming.
Right.
Are there some programs in other nations that you feel are being particularly effective?
Well, the only, a lot of nations are just looking at the bottom line, and they're just saying, it just makes economic sense to stop buying fossil fuels from other parts of the world to generate energy in their countries. Germany is taking the lead in sun. Many of the European countries, France, again, nuclear energy is quite controversial, but France produces most of their electricity from nuclear power for many, many years. And I think that that's a strong argument in favor of strong legislation, because a lot of times you hear, and I agree, where it makes sense to not rely on, the argument goes, we borrow money from China to buy oil from the Middle East, and we end up engaging in many of our conflicts there, or the reason why we've been in the Middle East for such a long time is because of our dependence on fossil fuel. So in terms of other nations that are starting to come around, I don't know particular programs, but I do know, for instance, like Australia, they had a new government that was elected in a few years back, and the guy ran on, we're gonna pass the, and he endorsed the Kyoto Protocol and all the rest. So many nations are taking the lead for various reasons, and setting aside the economic benefits of trying to get off of fossil fuels. Okay, thanks guys. Yeah.
Once again, thank you all for coming, and please pick up a grocery bag on your way out the door, and I'd also like to give a very genuine thanks to Westminster Christian Academy for hosting us tonight. So, good night all.